Hi, I'm Hossein and it's my second video on cncvid channel. In first video we learned how to create work plan in Powermill, and now it's time to make a toolpath in Powermill software. So if you're interested in machining or learn work with Powermill, you can subscribe this channel. Many parameters exist in strategy window, as we know. In this video we're going to know them very shallow, and the most important of that options like toolpath connection and feed and speeds. I will create a special video for them, but for now we're just knowing them so shallow for making rough strategies, or in other words, for making rough toolpaths. Now we're getting to know what is the nature of rough milling and build a few different type of roughing strategy in Powermill, which each one of them is suitable for a special material. Like some of them are good for aluminum, some of them are good for wood, or some of them are good for hard metal like steel and titanium or anything else. Now for making good rough milling and rough toolpath in Powermill, stay with me. At first, as you know, I create a block, and based on my block I create my work plan. After right click on my created work plan and choose work plan editor, I can change my work plan access site with a swap access, which we learned in previous video. Now I click on toolpath button, and from 3D area clearance headbar I choose model area clearance. From the opening window I start to set the options from up to down. An important point about block header is your block area will be detected for creating toolpath. If your material is bigger than your model, you can add your size block manually. Next header is tool. You should create your tool here. I will create a special video about how to build a tool in Powermill, but for now let's skip out this part. In this part you should set your base setting for your strategy. We have a form method here, but I suggest you choose offset all. It will be better for you. Offset model and raster aren't good choice for your machining, but also you can test them. Cut direction depends on what kind of material you want to machining, but mostly I set them as climb. What tolerance meaning here? For now you just know it's about point distribution, and nil.1 is a good set for roughing. And again I will share a special video for what exactly tolerance meaning in Powermill's strategy. Thickness mean same as a stock model in Fusion, or offset or contour. You know, it's about how your corner tool should have a gap from your model surfaces. While your tool is on the move on a special surface, how should be distance between two parallel segments in toolpath? This sub certain with step over. In roughing 80% of your tool dia, it would be good for that. And step down, detect your depth cut. In offset header, mostly I untick all the options, and outside in direction can be a smarter choice for you. I simulate my toolpath and you can see the result. In second shape of roughing, I choose vortex style. It's so important for choose climb direction in both box. In vortex, you should calculate your step power with following this formula. Multiply your tool dia by 128,000. It would be your maximum step power in vortex style. Maximum step down is equal with your tool cutter length. In vortex header, you have a two kind of style, from stock and from model. Based my experience, from stock have a better result, but this is on you. Target radius make your corner of your toolpath more smooth. You can field feeds and speeds options by your own experience about your tools which you use. But again, if you want to know what exactly should use feeds and speeds and the most important formula about that, I will share another video for calculating a right feeds and speeds for a special tool, for each general or special tool. From unsafe segment removal, remove segment smaller than. If I tick this option, it make my toolpath very safe. And from high speed header, you have one option, that this option make your sharp edge of your toolpath smooth, and the number which you enter to this box, how much your sharp corner should be. And in approach header, helical ramps is a general ramps, and you can use it anyone and anywhere in any strategy. And because I'm afraid of maybe my tool will break, so mostly I use the minimum angle for that, and I put 1 in max angle box, or 2 at least. With setting these options, I click on calculation, and this is the result. But let's make this little better. I activate the step cutting from a step cutting header. A step up box mean how much should my tool get upper and erase the remaining area after erase the block in its own step down layer. And usually I set 0.5 for detect material thinner than, less than half millimeter is a very little area, and I calculate the strategy again. Now see the result and compare it with the first strategy. We don't have to use area clearance for making roughing strategy. Sometimes we can use some tricks. For example, just let me do that and don't ask about the detail. Just let me show you how we can use one of these tricks, which is so special for materials like aluminum or wood. It's not work on steels, but it work on any kind of wood. This time please don't ask about details and what kind of job I going to do. Just see the result. I will totally explain it step by step, but for now I just want to show you how to use this. And if you already know something about Powermill, you can just get the idea and do this for your own self. But if you can't, don't worry, definitely I explain this trick step by step in future. Now see the result. Is that interesting? Did you ever hear anything about high-feed milling? Some kind of special tools exist for working with very high feed, 5000 millimeter each minute, but your toolpath should be especially options that on that case you can use it for high feed tools. If you don't have these options or don't set these options, truly you can't use it, and your special tool, your high feed tool, will be break. For changing your normal area clearance to a high feed area clearance, you should check two header. One head is high feed, head 1 is high speed header. You should change fillet corners at least in 0.5 in 2D style, and race line smoothing should be about 50%. And also you can tick the unsafe segment removal for sure. That's too important for make your toolpath safe. And you can see how it works. It makes your sharp corner of your toolpath so smooth, and you can pass it with very high speed than usual. Well, in this video we review the most important way for making a roughing toolpath in Powermill software. And now you have a very good look for rough milling in Powermill. Back I said there was some parameters like toolpath connection, collision and creating tool, which is a special other subject that I have to make a complete video for them, and we just knowing them very shallow in this video. Beside the area clearance, beside the model area clearance strategy, we have a rest area clearance strategy, which that is our next subject for our next video. So at least if you're interested in machining and Powermill, like I said, you can subscribe this channel and follow our next video for learning better to work with Powermill. Bye.